Hey guys, it's 12 a.m. and I'm going to talk about math. Let's go. Before I begin with this explanation, I want you to have very clear the three elemental trigonometric functions, which are sine, cos, and tan. I've graphed here some portions from these functions with its key points. Make sure you have this in your notes somewhere. Sine has a maximum when you input p halves. Of course, it goes from 1 to minus 1. So it has a maximum when you input p halves, minimum when you input 3p halves. Cool. For cosine, you create a maximum when you input 0 and a minimum when you input pi. Of course, trigonometric functions are periodic, so there are gonna be other maximums or minimums. Actually, every time, for example, for a minimum, every time you add or subtract 2 pi as many times as you want, you'll get another minimum. But whatever, we're just looking at this section. For tan, there are infinite vertical asymptotes. The first one's at p halves, next one is at 3p halves, and actually every time you add pi, you get another vertical asymptote. If you're confused as why are there so many pi's here, it's because we're measuring angles in radians. Remember, pi belongs to 180 degrees. Yeah, p halves is 90, and there's a video where I explain how to convert angles from degrees to radians. By default, we're going to do this whole unit in radians. Amazing. So what are we going to do in this lesson? In this lesson, we're going to manipulate, we're going to transform trigonometric functions. So take a look at this one. How do I represent this? In reality, we're not doing anything new. We're just going to apply what we learned in Unit 3 into trigonometric functions. So before I get into trigonometry, I want to review to a function in general in an xy plane. What happens? For example, I have a function, a certain function. I call this one f, so I'm going to call it g. Okay, gx. What happens to gx if I multiply it by a constant? I multiply the variable also by a constant. I add a constant to the variable, and I add a constant to the function. So what do all of these elements do? I'm gonna review it quickly, but if you forgot, you can go back to the unit. This number, what it does is it vertically stretches the function. Yeah. So if there's a 3 here, every point gets, sorry. If there's a 3 there, every point gets multiplied by 3. So vertical stretched. The b right there, what it does is it stretches the function horizontally like this. The higher the number it is, the more it gets stretched horizontally. See what it does? It translates, I'm trying to find another color. It translates the function horizontally. If you add a number, so if you add a positive number, you translate it to the left and a negative to the right. And the last number is d. Adding a constant to a function in an xy plane, what it does is it translates the function vertically. So you physically grab it and you translate it, you shift it. All of this is also going to apply with our trigonometric functions. So that's what we're going to see. All right, so I want you to take a look at this function. What have we done to the function? Okay, let's see. So, we have, what I like to do is I try to break down all the transformations that have occurred. So I'm going to begin by graphing sin, normal sin, something like this. Of course, it keeps repeating and then on this plane, but I'm just doing this section. Anyway, what have we done? The first thing I notice is that I have absolute value right here. So negatives won't be allowed anymore. So that's the first thing I notice, that this function, it's not going to have a negative part, it's going to bounce back. So it will keep bouncing and bouncing. And of course I said that I'm only going to look at this portion, so okay, it will bounce back. Nice. Okay, cool. What else have we done? We've multiplied the function by 3. So that means we've stretched it vertically by a factor of 3. If this used to be 1, now it will go up to 3, because I'm multiplying it by 3. So the new amplitude of this function is 3. So it's going to do something like this. Cool. We're also adding 1. So we're shifting it vertically by a factor of 1. Alright, if I draw this, it means that it used to start here. Now it's going to start here at 1. So, what's the new range going to be of this function? Well, this range will go from 1 to 4. That's for sure. Okay, and it will keep on repeating. Nice. Okay, so what about these two elements, this pi over here and this -1 over here? Now this part is a little bit more complicated, because this number right here is like the frequency of the function. Is how this number is right here is responsible for like stretching our function horizontally, and we're gonna usually call that value the frequency. Trigonometric functions are special, so we give special names to this constant. Although this is general for any function. We're just transforming a function. Anyway, so how can we know for which value I get the maximum, for which value I get this, for which value? How do I find out these values? What I like to do here is compare special points. For example, the maximum. I usually get it when my input is p halves. So sine, whatever mess you have in here, sine needs to receive p halves at the end of the day. When it receives p halves, it creates the maximum. Okay. So right now in here I have this mess. Whatever this mess is, if I want the maximum, it gotta be equal to p halves. So now we're gonna find the value of x that makes this true. Let's try to solve this equation. The 1, I'll bring it adding. So x will be 2. So x equals p halves plus 1 divided by pi, which is a pretty ugly number, but whatever. I'm gonna leave it like that. I'm not even gonna simplify it. So the maximum right here, we will get it at p halves plus 1 divided by pi, and the output is 4. Okay, nice. Okay, so we have everything. We have a function that when x equals 0 has a minimum, and when x equals this huge mess has a maximum. Of course it has other minimums and maximums. I mean, if this distance is this value, when you multiply it by 2 you get this value. And every time you add that value to 0, you'll get another minimum. Anyway, I'm gonna stop right here because I don't want to burst your brains into flames. Alright, let's take a look at this question. Let's try to solve it. So, they're telling us create a cosine function with a maximum here at 1/7 and a minimum here at 2/3. First thing I'm gonna do, I'm gonna try to graph the function. So maximum at 1/7, 1, 2, 3, 4, 5, 6, 7 here. Minimum 2, 3, 2 and 3 here. This is 3, this is 7. So more or less what this function will do is this, since it loops, will be a wave like this. Will look something like this. Alright, cool. So the range will go from 3 to 7. The domain, as you know, is infinite. Okay, I'm gonna start by identifying the axis of symmetry. So the axis of symmetry of this function is in the middle of 7 and 3. The middle is at 5. So here's the axis of symmetry at y equals 5. This is very useful because it reveals to me what the vertical shift is. Because the default axis of symmetry is at 0. If it has increased to 5, that means that we have shifted the function 5 units up. Because stretching the function the amplitude doesn't change the axis of symmetry. So it's like revealing what the vertical shift is. Anyway, I already know, so if I'm looking for all of these components, I already know that D must equal 5, because I've shifted it 5 units up. And what about the amplitude? The amplitude is also pretty easy. From the axis of symmetry, it's going 2 units up, 2 units down, yeah, to 7 and 3. So that's the amplitude. I already know that A is 2. Okay, I already got D and A. Let's try to find B and C. So to do that, I'm going to take a look at the maximum and minimum of this function. So the maximum of cosine, I usually get it when I input a 0, for example. In this case, I'm getting it when I input a 1. So whatever this equals to, if I want a maximum, should be equal to 0. And for which input do I want it now? I want it when x equals 1. So here's the logic behind it. Let's try to see. I want bx plus c to be equal to 0, because that's how I get the maximum. But in this case, they're telling me that x is going to be 1 for the maximum. So b times 1 plus c equals 0. This is an equation with 2 variables, so I can't solve this. I need another one. Let's try to look at the minimum. So for the minimum, they're telling me that we're getting it when x equals 2. And when is the minimum of cosine? The minimum of cosine, we get it here when we input pi. So my other equation will be b times my minimum, which is 2, plus c should equal pi, because that's how I get a minimum. And now I have a system of equations with 2 variables where I will find b and c. Let's get it. I'm gonna move this up because I need space. Vale, we already know how to solve system of equations, right? This one's really easy. I just need to subtract them and the c's will disappear. So b minus 2b, b, c minus c, nothing, 0 minus pi, and sorry, this was minus b. So, oops, what's going on? Ah! Okay, so, negative, they become positive. So b equals pi. Now that we know b, we just have to substitute it either here or in the other one, and we'll get c. So pi plus c equals 0. Therefore, c equals minus pi. And we found the equation, which will be 2 cos pi x minus pi plus 5. That's the equation that follows these conditions. I think it's pretty clear, right? Bueno, I think this is enough. This should cover the whole content from the homework. And just keep in mind, like, this is the logic we're going to use. Alright? Bye. See you in another life, in another time.